So we're going to have a look at some of these harder examples and just see how these work out. So in the first question here, it just gave a description and then I drew the triangle up. So it says in triangle PQR, so you draw a triangle with letters capital P, capital Q, capital R on it. Anywhere, it doesn't really matter where. Angle P equals 35 degrees, so you're marking 35 degrees wherever you wrote your P. And then little p equals 8 centimetres and little q equals 10 centimetres. So they're side lengths. Little p has to be opposite angle P, so it has to be here. And little q has to be opposite wherever you put angle Q. Alright, so now we're going to start with our sine rule for finding angles. Sine A over A equals sine B over B. So now, we've been asked to find angle Q. That's this angle here. I'm going to call it angle A for our substitution. That will make this little a, so just use your red pen to write these in. Then if we look at the other side length, this will be little b, and then opposite it will be capital B. Okay, so they're going to be the things that we put in. Let's have a look at what we've got. So we're going to have sine A, which they've got as Q, over little a, which is 10. Sine B is sine 35 degrees over little b, which is 8. So now we're going to solve our equation. Get rid of our 10 down here first. Instead of dividing by 10, we're going to be timesing by 10. That stays on the right, and we're still left over here with sine Q. Alright, so now we're going to our calculator to put this in. So type it in the way we've been doing, press your fraction key. We're putting in sine 35, close the bracket, down arrow, 8 on the bottom of the fraction, right arrow out of the fraction, times 10, equals, and write down the whole decimal that you get. And after that we're getting rid of sine, so the opposite of sine is shift sine or inverse sine. Keep this decimal on your calculator. So now we're going to be doing shift sine, answer, close the bracket off, press equals, and that's it. Now we're doing an angle and it's got to be to the nearest degree, so I'm happy with that because that is in degrees. If we go to the degrees minutes button, it will give it to us in degrees and minutes, and we don't want that for this question. So that's how many degrees we've got. We're going to the nearest degree, so we're rounding off to the nearest whole number. That's bigger than 5, so this is going to go up by 1 to 6, and the answer is 46 degrees. Now, with the ambiguous case, let's see what happens if we find the obtuse angle. So we do 180, take away the 46 degrees, and that will leave us with 134 degrees. And we want to check if that actually could happen. Right, so if you have a think about our diagram and just look at the angles, we don't really care about anything else. Just look at the angles we've got so far. We've got 35 there, and we're wanting to know, could this be 134 degrees? Well, yes, it could be, because if we add these up, we've got 35 plus 134. That gives you 169 degrees. And because that's less than 180 degrees, then yes, it's all good. Okay, because that leaves us with 11 degrees we could still have for our third angle, and that's possible. So in the end here, you're going to write, therefore, our angles for Q are 46 degrees, and the other one is 134 degrees. So both the acute and the obtuse angles are possible. So let's have a look at what happens in this next question. So in this one, I haven't written the question down, have I? We're going to find theta. Let's make it correct to the nearest minute. Right, so we'll start our question the way we normally do. We can see we're finding an angle because we're looking for theta. So we write our formula down, sine A over A equals sine B over B. Right, now, that is what we're looking for, so that's going to be angle A. The side opposite it would be little a. Now, once you get to there, you see you've got a bit of a problem because we need to know all these numbers to be able to continue. So this is not looking good. So this question's a bit tricky. We'll just write it down. It is one of the harder questions, and now we're going to do a rethink. Okay, so I'm not going to do that at all. So I'll change colours to my blue pen and show you what we are going to do. I'm going to get rid of that and think again. All right. It all depends on what's going on with the sides. So you've really got to concentrate on the sides here. So we do have an angle and the side opposite it. Now that's all our stuff for B. All right, so I'm going to use that as our little b, and the angle opposite, we're happy with that. We've got those numbers. So in fact, I can put that in right now. I've got sine 117 degrees over 12.7. The problem is the other side here. Now, we are finding theta, but we had a real problem because we did not have anything to write down the bottom here. You must use the sides. Really important. Look at the sides. If you start looking at the angles, that's when you're going to get yourself into a mess with the harder questions. So we're focusing on sides. So I'm going to make this be my little a. Right, so let's put that in, 5.4. And that looks like we're going to have this as angle A. So we're going to find that angle. So let's go ahead and find what this angle actually is. And that's what we're going to call angle A. Now I know they didn't ask for it. They asked for that one up there. But we can't find that one because we don't have that opposite side. So we've got to use the two sides they have given us, and we're using the angles opposite them. Later on, we'll work out what the actual answer to theta is, but let's just get on with this first. All right, so we're going to get rid of the 5.4. So we're getting rid of divided by 5.4 by coming over here and timesing by 5.4. And we're going to go to the calculator and find out what this decimal is. All right, so you can start putting that in your calculator. Fraction key, sine 117 degrees. Whoops, let's go back up there. Close the bracket, down to the bottom, 12.7, right arrow out of your fraction, times 5.4. Should be looking like that. Press equals, and that's what we've got. Write it down. All right, so now we're finding A. I'm not getting rid of this off the calculator yet. We're going to do the opposite of sine, so we can get the A by itself. So we're going to do shift sine of that decimal. So remember what to do when we're trying to say and having to write all this again in the calculator. We just do, that was our last answer. So we're just going shift sine, you don't have to clear it or anything, just shift sine, answer, close the bracket, equals, and we are to the nearest minute on this one, so I'm going to press the degrees, minutes, seconds button. Because our seconds is 45.59 seconds, I'm going to go up by 1 in the minutes, so it's 22 degrees, 16 minutes. All right. Now remember that your calculator will always give you an acute answer. Always. Okay, now let's think about it. If that answer up there that we just found, let's go and write it in now, that is now 22 degrees 16 minutes, then how are we going to find theta? Well, you know the angles in a triangle add up to 180. So if we do 180, take away 117, take away 22 degrees 16 minutes, we'll get our answer for theta. So let's do it. Okay, we'll go to the calculator and work out what that is. So 180, take away 117, take away, you don't have to press the degrees button, not yet, but you do now. 22 degrees, 16 minutes, press equals, and then press the degrees button again. 40 degrees, 44 minutes, no seconds. So 40 degrees and 44 minutes. And that's the answer to the question. So they're a little bit tricky, those questions. We didn't have any case for an ambiguous case here, because once you've got an obtuse angle in a triangle, you can't have another obtuse angle. So I'll just write that down as a note at the end. If you already have an obtuse angle in the triangle, you cannot have another obtuse angle. So they already had one there. And even if you think about trying to draw a triangle with two obtuse angles, imagine what it would look like. There's an obtuse angle. Let's try and draw another one. You can't get the three sides to join up, so it's impossible. It does not form a triangle. Okay? So now it's your turn to try this work. All right, just make sure you practice it. You will not be able to do this work, and you will have a mental block in the next exam without practice. So write your formula down first. Actually, draw your triangle first. Mark on all your letters, your A's and your B's. Then put your formula down and then sub into it and keep going with it. Towards the end of the exercise is when you're going to have things like the ambiguous case, and you get ones like this where you can't find the angle they asked for straight away. It happens in the last two questions, so just be careful when you get to those.